Hello. Good morning, everybody. So let us begin. Circular motion. See, you remember we finished the kinematics of circular motion. Remember this?
Yes, sir. Completed.
Right. See if you can remember what we have studied earlier. See here, when a particle moves in a circle, what are the various parameters that control the motion? Let us see. See, this is the location of the particle of mass m. Compulsorily, there should be a tangential speed.
Radial acceleration.
This is a These are minimum requirement. Okay. Now you can see and the other one is understood this? Clear? Now, for example,
Yes, sir.
so here if V is 0, AR is not 0, what will happen?
AR will remain in the along direction of radius.
Yeah. If V is not 0, AR is 0.
Particle moves along the tangent.
That is also a straight line now.
Yes, sir. Straight line.
Understood this?
Understood, sir.
Do you agree with this? So remember that without these, you cannot, a particle cannot move in a circular path. Understood this? Clear?
Understood, sir.
Yes,
Clear.
sir.
Next. Note on this. Follow this.
Yes, sir.
Return
Yes,
this.
sir. 1 minute.
1 minute, sir. 1 minute.
Shall I turn this?
Yes, sir.
1 minute.
1 minute, sir. 1.
Completed.
Yes, sir.
Yes, sir.
Then centripetal force due to what?
Centripetal action.
Hmm. I will do this.
Change in direction of motion, direction in a circular path.
Understood this? Thus,
Yes.
understood this?
Understood, sir.
Right. Now, if we apply a tangential force, Remember that net force. It's just like what is effect net force along
X direction.
X-axis.
Y direction.
we have net force okay. This is only called
Centripetal.
it's not a new force. Understood this?
Yes.
Yes, sir.
Here turn that.
Sir,
Yes,
1
sir.
minute.
Completed.
Sir, 1
1
minute.
minute.
Return this.
Yes, sir. Yes, sir.
Yes, sir.
Complete.
Completed.
So we can any force return this. Hello.
Yes, sir.
Sir, 1 minute. Camera focus is not.
See here, suppose a car or something, a vehicle is moving like this, for example. It's a vehicle, it is moving like this. Okay, say in this direction. It is moving like this. Now, any object inside this. Now, this is the frame, no? Okay,
Yes, sir.
so this frame has which frame?
Acceleration.
How much? Remember V square by R.
Yes, sir.
Remember earlier we discussed all this.
Yes, sir. This is the tangential speed. Radius, outward, path.
You agree till here?
Agree, sir.
Now here, we agree with the nut.
Agree, sir. Mustard pseudo force. MA square. Sorry, MA. The minus of acceleration. Velocity. Plus report.
Okay,
Yes.
minus of V square by R towards center now.
Yes, sir.
Okay, so that means I can say that mass of object minus of V square by R towards center means it is V square by R away from center now.
Yes, sir. Everything, sir.
Do you agree with this?
Yes, sir.
Shall I turn this?
1 minute, sir. 1 minute.
Sir, can you show that above portion also, sir? Thank you, sir.
Shall I turn this?
Yes, sir.
Hello?
Yes, sir.
Wait, sir, 1 minute, sir.
Tell fast, man. Finished. So remember that he is nothing but clear.
Yes, sir. Clear.
So this is what he gets centrifugal force. Means a force that acts away from the center. Clear enough?
Clear, sir.
See, real forces means there should be some like gravitational force, which arises what?
Due to, so,
Agreed.
yes, sir.
Tension. Why does it arise?
So because of
Due to
induction
Earth.
or attraction.
Molecular interaction. For this, clear enough?
Clear.
Friction also same thing. Correct. That is the reason why, see, suppose is the Earth. This is mass m, this is Earth mass m. This is mg, this is an mg. So one is the action reaction pair, no?
Yes, sir.
Clear? Now pseudo forces will not have action reaction pair. They do not have,
Action reaction pairs.
understood this?
Yes, sir.
Shall I turn this?
One means one.
The remaining part of circular motion already you know.
Yes.
Shall I turn this?
1 minute.
1 minute, sir.
Finished.
Yes, sir.
Now take some problems. The remaining part of circular motion we have completed earlier. Hope you remember.
Yes, sir.
Is it visible or not?
Visible, sir.
See here, table is horizontal now.
Yes, sir. Horizontal.
This is 1 kg. It is tied to a string. It is fixed here. This is moved with constant speed. How much?
10 meters.
See, remember, first thing you have to do is observe what are the forces. mg is downwards. That is balanced by what? Normal reaction. Now this is the tension. So here you can see N is balanced by what?
By
Agreed. For every problem you should do the same way. What is the unbalanced force toward the center?
centripetal force.
What is that here?
Tension.
Tension.
Therefore, tension provides the centripetal force. Now we can use that net force toward the center. Newton's law is that or no?
Yes, sir.
Do you agree or not? So here this is the tension. Mass is 1 kg. acceleration toward the center is what? AR. Now this is mass is 1. This is nothing but mv square by r. Agreed? So this is 1 into 10 square by radius is given.
1 meter.
Understood how to do? Simple application of Newton's law is not a separate chapter. Actually, from now on, all chapters, if you know this previous chapter, is very easy. Shall I turn this?
Sir, one doubt, sir.
Tell.
Sir, here this block is moving on the table now, sir.
Hmm.
So,
Hmm.
questions like if we are rotating a string in the air, in such
Hmm.
case, this normal force will arise, sir. So, because normal force is a
Then
contact.
actually, this, in that case, the particle will neglect the gravitational force he has to give.
Okay, sir. Okay, sir.
Otherwise, he can never rotate a particle such that always it is in a horizontal plane in air. Always there will be inclination. You can never rotate a particle in horizontal plane because mg is not balanced here. Okay. So
Yes,
for
sir.
that reason, this is tension. This has no component in this direction. So this is one centripetal force, this unbalanced force. So automatically the particle will slightly fall like this and it will move like this actually. Okay.
Oh, sir.
So he gives in books mean that fellow means that neglect the gravitational force. He'll say mass of 1 gram, 2 grams like that. 2 gram means 2 into 10 power minus 3 into gravity 10. How much it comes to? 10 power minus 2 is the force, almost negligible. No?
Yes, sir. Almost negligible.
Shall I turn this?
Yes.
1 minute. Done, sir.
See, a ball understand?
Yes, sir.
Understand the question? You know what is a groove? Huh?
Yes, sir.
What is groove? This is followed.
Followed, sir.
You are able to visualize this. The small part is removed like this. This is the particle, it moves along the groove. You are able to visualize.
Yes, sir.
I removed one small circle when it can move no like this.
Yes, sir.
Followed.
Followed.
Forward, sir.
That means it is moving along this. Now can you tell what are the forces on this?
Yes.
One is a normal reaction of this. This is another one. This is mg. Any other force is there? Hmm?
Centripetal force.
Pardon?
Centripetal force.
I am telling you that only centripetal force is not a new force. N1 provides the centripetal force. I gave very clear, this is a mistake even lecturers do. Centripetal force is not a new force. Force along x-axis. Whichever force is there, that is called centripetal force. Here, which force is there? Unbalanced force towards center?
N1.
N1.
Hmm.
N1.
And
So
sir.
N1 is only the centripetal force. There is nothing separate force. Be careful with that.
Yes, sir.
Okay. Now you can see vertically along y direction if you take, there is no acceleration. No? Followed.
Followed, sir.
Radially, if you want to take this vertically, Fv equals m into Av. There is no vertical acceleration. No? Similarly, radially you have this. No? Only force is N1. That's all. Substitute the values. That is what is asking now.
Yes, sir.
Clear?
Yes, sir. Clear. Yes, sir.
Remember, centripetal force is not a new force.
Sir, it is any force that is acting towards center is called centripetal force. That
Centripetal
is
force.
not
No,
any
it is
separate
not.
force is
No.
not there.
I wrote that very clearly previously. The centripetal force is not a new force. The sum of all the force, net force towards the center is called centripetal force.
Okay, sir.
Yes, sir. Understood.
This is what I wrote here. Any force or component of any along the radial sum may be called as centripetal force. You wrote this now?
Yes,
Wrote,
sir.
wrote, sir.
Yes, sir.
Shall I turn this?
Yes, sir. Yes. One.
Completed.
Yes, sir.
The coefficient of friction. Following this writing? Hello?
Following, sir.
See, turntable means any table which can turn, that's all. Don't think what is a turntable and all. It is a table, okay, about this is on the ground. Now this is able to rotate like this. That is the meaning of turntable. Understood this? That
Yes, sir.
means this angular velocity is omega. What he says is there is a block placed here. The edge of this. Now, why does it rotate? It's rotating means compulsory one force should be there. What is that force?
Centripetal force.
See here, there is normally action is like this, mg. There should be some force, otherwise it's towards the center, otherwise it cannot move in a circular path now. Now can you tell what is the possibility, who provides that? There is no tension. Any other thing is there? Observe like that.
Tangential acceleration.
Frictional
Huh?
force.
Tangential
Pardon?
acceleration.
No, no, tangential acceleration is there, that doesn't move. No, tangential acceleration is not necessary. Tangential speed is necessary.
Sir,
There must be a force toward the center, that is only friction, no?
Sir, so block is falling.
yes, sir. Friction.
Only friction only is there. Friction. Understood this?
Yes, sir.
See here, there may be a, suppose this is this. This is a particle. Now, friction may have two components now. One is towards this, the other is along the motion now. This is one component, radial component. You are able to understand or not? This is a radial component, this is the tangential component. So that the net frictional force will be this now. You have done earlier no? Along XY.
Yes, sir.
Yes, sir. Yes, sir.
Same way. You can have friction in any direction no?
Yes, sir.
Clear?
Clear, sir.
So this FR is moving along the FR is toward the center, FT is tangential to that. Clear?
Yes, sir.
Yes, sir.
So here what he is asking? Find the force, frictional force. That means there is no tangential frictional force. See, hello, what he says that constant omega. What is the meaning of it?
Uh,
Omega means
No time.
constant V, no?
yes, sir.
This implies that there is no tangential force, no?
Yes, sir.
Huh?
So doing problem is different. Analyzing a problem should have no tangential force. Understood this?
Understood, sir.
What books do is they give one solution. They won't explain anything. So there is constant, he said. Constant means omega is constant means V should be constant, no tangential force. That means therefore we can say here so only friction will be along which direction?
Sender, towards sender.
Radial direction.
That's all. Now your problem is solved. No? So now you can see FR understood this? Is it clear or not?
Clear, sir.
Vertical direction. V means vertical direction. Understood this?
Yes, sir.
Shall I go ahead?
1 minute, sir.
These are the basics which you should have in-depth knowledge, strength, grasp. Shall I turn this?
1 minute, sir. 1 minute. Completed, sir.
Next. See, this is the convex bridge now. Now the far is at the highest point here now.
Yes, sir.
He is asking, see here center of curvature will be this side now. If you complete this circle, center will be in which side? This is the center now. So that means this is mg normal reaction. Agreed?
Agreed, sir.
So this is the tangential speed. Now what is the centripetal force?
mg square by r
And
Centripetal force is nothing but
towards center. Mg minus n.
so this Fr. So this is mg minus n. The force toward the center is opposite to the center now.
Yes, sir.
Agreed?
Agreed, sir.
So remember, a normal reaction is less than mg. So normal reaction need not be equal to mg always. Followed?
Yes, sir.
So return this.
1 minute.
This week can you write whole syllabus once cumulative just for fun? No.
yes, sir.
Next week you'll write.
Ready, sir.
Anyhow, that 25, 26 people are only attending the class. 31 are coming, man. Slowly, now 22. Where they'll go so fast, I don't know what they'll do.
Sure, sir.
So return this.
Yes,
Sir,
sir.
1 minute.
Green.
Done, sir.
See, this is the concave, no? You're able to follow or not?
Yes, sir.
Yes, sir. Concave.
Now, center of curvature will be this side, no?
Yes, sir.
Yes, sir.
So this is the car, no? So this is the tangential velocity, normal force, mg. What is the net force toward the center?
N minus n. N minus n.
You can see n is greater than mg, no?
Yes, sir.
Yes, sir.
Black.
Hmm.
Blue only.
పర్వాలేదు కొట్టిడే
Clear?
Clear.
Yes, sir.
Shall I turn this?
1 minute. Sir, I didn't understand how are you saying that n is greater than mj or less than mj?
Hopeless fellow. What is this mean? Mg
Plus.
plus something. This is one positive, no? Is it not greater?
Yes, sir, it is greater, sir. But
No, that's why same thing I wrote. Suppose V is 0, N equals Mg. So generally people will take that normal reaction is always equal to Mg. That is wrong. Okay. It need not be always equal to Mg. It may be greater than Mg or less than Mg.
yes, sir.
Shall I go ahead?
Yes, sir.
Yes, sir.
So remember that always in circular motion, what is that you are doing? You are just trying to find the net force towards the center. Now let us take some simple applications of the circular motion. See, suppose you take a string, take on some string, okay? This is fixed. Now suppose this is some particle. It is made to move like this on a circular path. Imagine, can you tell what will happen to this? Means what is the shape the string will sweep?
It is like this
Cone.
spiral.
It is a cone or not? Ah, that's what.
Yes, sir, cone. Conical shape.
That's what. That much if you know, that's enough. Okay. It sweeps a cone or not?
Yes, sir. Yes, sir.
You're able to visualize this?
Yes, sir. Yes, sir.
Yes, sir.
Clear or not?
Yes, sir.
So this is what we call it as a conical pendulum. Clear?
Yes, sir.
Yes.
Yes, sir.
Understood this? Clear? Hello?
Yes.
Now you take at any point, let the speed V. This is the tension now.
Yes, sir. Thank you.
Agreed or not?
Agreed, sir.
Agreed, sir.
Now this is the semi-vertical angle of the cone, no? Agreed or not?
Agreed, sir.
This is theta, no?
Yes, sir.
This is the tension, no? Now can you tell this can be resolved into what? One
T,
is,
T sin theta and T cos theta. T cos theta. T sin theta.
agreed? Correct or
Agreed.
not? That
Follow.
means the same thing I am showing here. It is having one t sine theta towards the center. And another one is this. Do you agree with this or not?
Agreed, sir.
Is it clear?
Clear, sir.
So this is t cos theta. What is this?
T sin theta.
And this is mg, no? Do you agree with this? I can write like this. In the vertical direction, the forces are balanced or not? There is no acceleration in the vertical direction. Do you agree with this? Clear?
Agreed, sir.
Yes,
Clear.
sir.
Toward the center you have only t sine theta is there. Do you agree with this? V is the speed of the particle, no?
Yes,
Any
sir.
doubt is there? Hello.
No doubt, sir.
No doubt, sir.
Clear or not?
Clear,
So
sir.
from these two equations you can find t sine theta by t cos theta
Tan theta.
equals mv square by r by mg. What is tan theta? V square by rg. Do you agree with this? So V equals what? Rg tan theta. Do you agree with this? Clear?
Agreed, sir. Clear.
Now from this triangle, can you tell what is sin theta? Sin theta is nothing but r by length of the string, no?
Yes, sir.
L is what?
Length of the string.
So here r can be written as L sin theta, no?
Possible, sir.
Clear?
Clear, sir.
Now you can see that speed is independent of mass, no?
Yes, sir.
So like that he'll be asking find the tension. Suppose they ask tension, how you will find that? Speed is given. Suppose we need tension. To find T, he may ask anything, no? What you'll do? Square and add, that's all. Do you agree with this?
Agreed, sir.
So like that, whatever he needs, he can do. I'm just explaining what is a conical kingdom, how does it function. So you have to mold your thoughts according to the situation of the question. Clear?
Clear, sir.
Any doubts are there in this?
No, sir.
No.
So this week you will have the circular motion basics only and friction. Friction already we have completed, that will be at a higher level, okay?
Yes, sir.
Okay.
Right, go to your math class. Any doubts are there, you can ask me now.
No. Clear.
Completed.
Sir, 1 minute.
Completed, sir.
Right, we'll meet tomorrow, okay?
Sir, bye.
Okay, sir. Thank you, sir.
Yeah,
Bye.
people are following or not?
Following.
Following, sir.
And why then many people are absent? That's what wonder. First time I'm experiencing this. Hmm. The same case for all classes, huh?
Yes, sir.
Almost all classes same.
Every class is only happening.
Hmm. Hello?
Every class is this only happening, sir. Very few students are coming. That's
Masi is not there in the meeting.
no, sir.
No.
So he's not taking. Physical classes will start shortly. No? Okay, go ahead then. Okay, you're following or not? That's what I need. Let them be absent or not.
Following, sir.
Right, right. Take care. Bye.
Thank you, sir. Bye.
Thank you, sir.
Thank you,
Bye.
sir. Bye, sir.
Bye. Bye.